Hello and welcome to our third section in chapter 11. Today we're going to be talking about area still of circles and sectors of circles. So, hopefully you know this. The area of a circle, well, let's define a circle. A circle is a point which has a series of points that are equidistant. Well, that's not how you spell series. Points that are equidistant. Equidistant. And equidistant just means equal distance from that or the center point. So, as you know, we could draw a circle, and then our center point, everything on the outside here is equidistant to the center, okay? And there are a couple components that we need to know. Remember, hopefully you know this already from geometry, from elementary geometry, is that when we have a line that goes through the center and lands on both ends of the two ends of the circle, that is what we call our diameter. And then half of that from the center to an endpoint, that is our radius. Okay? We also need to know a couple things. The diameter is equal to 2 times the radius. So that is important to know. We also need to know the circumference equation. So circumference is equal to pi times diameter. We also should know that pi is approximately 3.14. If you want to add some more decimals, 1592, that's okay. But for the most part, it's important to use pi as its own value. We're going to be using pi in our answers, and I'm going to be expecting to have pi in your answers as well. So, I will show you where pi is on this calculator. Clear this out. If you look closely, on the far right side of our calculator, above the division symbol, there's the up arrow, and in blue, above the up arrow, is the pi sign. So hit second, hit the up arrow, and pi shows up. And as you see, our pi is 3.1492654. This is an approximation. Okay, so it's better to just leave it as pi, especially if it's like area. So the area of pi is going to be the entire lesson, for the most part. It's the title part of our lesson. Area is equal to pi times radius squared. Okay, and it's very nice. It's very convenient if you're given the radius. But if you're given the diameter, it shouldn't be too hard because radius it's just half of the diameter. Or even more so, if you're given the circumference, we should be able to solve for the area regardless. Okay, so let's take a look at a quick example. So let's say example 1. I'm going to draw a circle. Draw a circle. Draw a circle. There you go. I'm going to draw a center dot, and I'm going to say that the diameter, this distance diameter, is equal to 22. Let's say inches. I got the pizza, 22-inch pizza. That's a very big pizza. But yeah, 22 inches. That means the radius is equal to half of that, which is 11 inches. Okay? Then, what we do here is we take that, we throw it into our area equation. Area is equal to pi times radius squared. 11 squared is 121, so we can say the area is equal to 121 pi inches squared. Now this is the exact answer, 121 pi inches squared. If I were to ask for the decimal answer, we would just throw this into our calculator, 121 times pi, which is equal to 380, and then this is where we would round. The fact that we are rounding means that this should be an approximation, because anytime you round, it is not the exact value anymore. And let's say I want to round to the hundredths place, 132, just rounds to 13 inches squared. So, depending on the problem, it could, more often than not, the exact answer is the best answer. But if I ask for the decimal version of it, it's okay to write it as a decimal. Just make sure you use that approximation symbol. Okay, so that's area. What about, what if I said we had a pizza slice? Let's use this, let's make this a different type of, different slice of pizza. We can draw another circle. Much better this time around. And what if I asked you to solve for, let's say, here's the center. What if I asked you, let's say this is, instead of, let's say this pizza slice has a radius of 9 inches this time, okay? Well, we could always solve for the area of this entire pizza. And let's try this pizza out. Let's just shade this around. And it seems like the most popular pizza, according to some of my other classes, is pepperoni. So let's make some pepperonis. Okay? And we could always find the area of this entire pizza. So area would be equal to pi times radius of 9 squared, which is, area is then equal to 81 pi inches squared. But that's the entire pizza. What if I wanted to solve for a slice of pizza, or let's say even half of the pizza, right? Let's say like this half. Let's say this half was eaten. We have half the pizza left. We obviously would just cut this in half. Going a step further, what if I said I wanted 1/4 of the pizza? What is the area of this 1/4 of it? Well, we would obviously cut this in by 4. Where it gets weird is, what if I asked for a pizza slice that actually has an angle measure? Well, the angle measure here, let's say if this is 60 degrees, okay? Now, the concept here is we're gonna only focus in on this sliver of the pizza slice, or this particular pizza slice. So, what we do is, we should hopefully know that and this would be actually good to put up here, every circle has 360 degrees inside of it, okay? So we should know that all around this is 360 degrees, even internally, 360 degrees. And since we're only concerned about 60 degrees of them, we actually take that angle measure into account. The way we solve for this is, let's title this area of a sector. The area of a sector is equal to the angle over 360 degrees times the area of a circle, pi r squared. And hopefully this makes sense, because when we're thinking about half of a pizza is 180 degrees. And 180 degrees over 360 is equal to 1/2. Then I also said, what if I talked about 1/4 of the pizza, right? 1/4 of the pizza is 90 degrees. 90 degrees is the 1/4, and that's, you take 1/4 of that value. But if it's 60 degrees, then we would just take that 60 and we would plot it into for this angle. So in this particular case, we're gonna say area is equal to 60 degrees over 360 degrees times pi r squared. We already have this actually, because we already calculated the area of this, 81 pi, okay? then we could do some simplifying, or we could just do some multiplication. 6 over 36 is actually equal to 1/6. 1/6 times 81 does simplify a little bit, but you could just use your calculator at this point. The exact answer would be 81 divided by 6. They're both divisible by 3. So we could say 27 over 2 pi inches squared. That's the exact answer. If we use a calculator, 27 divided by 2, multiply that with pi, and that's equal to 42.41. So area of this particular section or the slice is equal to 42.41 inches squared. Okay. Something's off about that. No, it's not. That should be fine, actually. All right. So another thing I did forget to mention is that here, this 60 degrees, this angle here, is what we call a central angle. Okay? And then in blue, I'm going to call this particular piece of this part in the crust is what we call the measure of the arc, because it's like the arc of the crust. And ironically enough, these are congruent to each other. So sometimes you'll actually see this marked as 60 degrees, the measure of the arc. And just know that you could still plot that in properly for the equation of a sector. Okay? So these are your two equations that we need to know. Area is equal to pi r squared. Area of a sector is equal to the angle over 360 times pi r squared. And then some of this other side information is very important to know as well. All right, so this is area of circles and sectors. If you do have any questions, please bring them to class, and I'll see you in the next one. Bye.